let's start off with sort of a general question. That question is, how far is it to the interstate? Well, if you think about it, and this is from the school is about a mile from the interstate. And so if someone drives up and says, hey, how far do I have to drive to get to the interstate? You'd say a mile. What would happen then if he were to back up an inch? Dude. He says, how far am I from the interstate now? You'd still say a mile. You wouldn't say a mile and an inch. Why not? Well, because when you gave the distance, you gave it in miles to the nearest mile. You were only measuring it to the nearest mile there. You didn't measure it any more precise. If you said that, oh, it's a mile and an inch now, that would mean that you knew that before that he was exactly 1 mile to the nearest inch. And now, he's just an inch more than that. So this is an example of somewhere where we have to be very careful with how we describe our measurements. Similarly, is if we tried to use a very large unit, like say gigameters, you know, 1 billion meters. If I said, how many gigameters is it to the interstate? Well, near-wise, it'd be 0 to the nearest gigameter. So I'm already at the interstate? No, not at all. It's just that if you're not careful about how you round things, then you can basically give inaccurate data. The term for this, the technical term for this, is called precision. And whenever you measure something, you always need to indicate how much precision you had. If you don't, then what can end up happening is you can say, I measured this out, and I measured this to be, 30 centimeters. Well, 30 centimeters could tell me that you measured this all the way out to 30.000 centimeters. You measure this already out to the thousandths place, and it's exactly 30 centimeters. Or it could mean you were just sort of lazy and said, it's close to 30 centimeters, and because it was like 27.4 or whatever. But you said it's close to 30, I'll call it 30. Is that if then someone says, I'm going to add something that's a centimeter to this, if you were just rounding to the nearest tens of centimeters, then adding exactly a centimeter to it, someone's going to think it's 31. Is it actually 31? Maybe not. I mean, it could be anything from 26 to 35 if you don't tell them exactly how far that you measured in the first place. So significant figures describe the precision of measurement, how precisely you measured something. Now, if you see a number that's been written down that's already been put into significant figures, sometimes we have to figure out exactly how many significant figures does that number have, so that when we do a calculation with it, which we'll do later, that we're able to actually measure things and do those calculations correctly. So the first rule for significant figures is that all non-zero digits are significant. Okay? So let's take a look at how this would work. Let's suppose that we had a number, that it was something like this. It was 709. So this is our number here. We want to figure out how many significant figures does this number have. First rule is this. All non-zeros are significant. Is the 7 a non-zero digit? Yes, so it is significant. Is the 9 a non-zero digit? Yes, so it's significant. So we know that this has at least 2 significant figures here. Next rule. Zeros between non-zero digits are significant. Is the 0 in 709 between 2 non-zero digits? Yes, it is. So it's significant. So this one right here has 3 significant figures. So we can know that right there. Alright? So that's what we've got here. What if their 0 is not between non-zero digits? These are our next 2 rules here. So let's see what we've got for them. So the first rule that we have, this is the third rule, zeros on the far left, leading zeros are never significant. Never significant. That's just an overall rule. Can't get around that. So if our number was something like 050, we have 50 we're going to write it out this way, is we know that the 5 is significant because of the fact that it is a non-zero digit. The first 0 is not significant because it's a leading 0. It's on the far left. It's never significant. So that one's like, nope, not significant here. What about that last 0? Well, this is where we go to rule 4. Zeros that are on the far right of a number, that is trailing zeros, are only significant if they are to the right of the decimal. And so, where's the decimal here? Well, the decimal should be right there. And so, because of the fact that that 0 is to the left of the decimal, it's not significant. This number only has 1 significant figure. Okay? Now, what if instead this had been this number? 050.00. Well, let's take a look. The 5 is significant because it's not 0. Are there any zeros that are trailing zeros that are to the right of the decimal? Yes. There's one out here and one right here. But since the 5 and this 0 are significant, any zeros in between them have to be significant too. So this one is also significant, and this would have 4 significant figures.